21st century focuses on % of passengers have said they would previously have used a car for their trip. So what makes fast tracks so attractive? Dedicated traffic-free bus lanes with priority at junctions. Comfortable and spacious, high-quality, low-emission buses. High-quality stations and waiting areas. Convenient real-time passenger information systems. Off-bus
Ladies and gentlemen, I have the pleasure to invite you to our cozy final round of the day, Innovators Corner. The innovators are to my right and to my left. I will introduce them to them whenever they give their maximum 15 minutes presentation and what's so special about them and their innovations. My name is Axel Ahrens. I'm professor of transportation planning at the Technical University in the neighboring town of Dresden. According to the East European tradition, we have in Dresden an interdisciplinary, rather big faculty for transportation with sociologists, economists, and lots of engineers, 30 professors. So it's a quite respectable faculty and rather unique in Germany, the only one of this kind. We begin our presentations with Hossam Abdel Gawad. He studied civil engineering in Cairo, got his bachelor and his master, focusing on traffic, highway, airport engineering. Since 2006, he is a PhD candidate at the University of Toronto, and he is focusing there on intelligent transport systems. The issue of his dissertation is optimization of multimodal evacuation of large-scale transportation networks. Challenging task. And I have a colleague in Dresden, he deals with Mecca, and he modeled the pedestrian streams in Mecca whenever something happens there. I wonder whether you have contact with him. And now I'm allowed, since we are a small group, to tell you a little secret. You will see him tonight on stage again because he won the Young Researcher Award with this research, and I'm very curious what it's all about, and you have 15 minutes.
Good afternoon, ladies and gentlemen. Today I will just, it's very challenging though to have 200 pages of dissertation to be only in 10 minutes or 12 slides, but I will do my best to convey my message shortly here. This work has been supervised by Professor Bahar Abdelhai, who is sitting over here, and also I want to acknowledge him for his sincere guidance during the past 4 years. So as you can see, this framework is about optimization of multimodal evacuation of larger scale transportation networks. First of all, just to put things in the right context, I'm here talking about natural or man-made disasters in large cities. How can we deal with them? So the problem basically is we have a sudden shear in demand, which is people that we need to evacuate. We have a limited supply, the infrastructure capacity, and we have chaos associated with such as uncertainties and emergency cases. And the solution basically that I'm presenting here is basically we are controlling the demand. In other words, how can we schedule the evacuation process as well as providing some information about the destination and choice, where people should go to. We are dealing with controlling the supply, which is the actual network through routing signals and some advanced traffic management strategies. So if you look at the problem, it's a multidimensional problem. If this is a search space, as you can see in here, you can tackle the problem from multidimensional. So for example, we can schedule people, which basically providing them information about when should you go or when should you start the evacuation, and the destination choice, where should you go, as well as assignment or the routing, which route should you take. So those three pieces of information are really important in case of emergency evacuation, as well as I'm dealing with traffic signals in case of emergencies to adapt with the traffic fluctuations. The contraflow or reversing traffic directions is not within the scope, but these three main or four main strategies are the problem here that I'm trying to solve in order to address one of these objectives. One objective might be you want to minimize the network clearance time, or you want to minimize the total evacuation time, and so on and so forth. So this is actually the most important slide. This is about the framework. The framework actually is divided to three main layers. The first layer is about having an evacuation demand estimation model. The ultimate goal of this layer is basically to identify where people are located by time of day and by which mode. And then the output of this layer is fed to two optimization engines. The one on the right, which is your left, deals with automobile evacuation, so having an optimal plan for people who have their cars. The one on the left deals with the transit evacuation through having an optimal routing and scheduling plan for transit buses as well as subways. And then the two frameworks are combined together in order to have an optimal multimodal evacuation framework. I'll be a little bit here technical about having a definition for the different time structures and how this is reflected in terms of different objectives. One important thing that we have to realize that people are loaded to the network according to the so-called loading curve. And if you look at the problem from a queuing perspective, so those people get into the network, they spend some time traveling through the network, and then they get out of the network, which is mimicked here by the evacuation curve, ET, which is in the red color. The area between the two curves is actually the total travel time that those people encountered while they are traveling through the network. So one objective might be we want to minimize this area, so we want to minimize the travel time of people in the network. However, in case of non-notice evacuation events, when you have something happened instantaneously at time 0, then the area between the vertical axis, which is actually the figure in the middle, and the loading curve is the waiting time of people at origins. And this is very important in case of transit evacuation or people who are captive to certain modes. So if you want to minimize the waiting time of people at transit stops, then you should consider this area. An ultimate goal, if you want to minimize the total evacuation time, which is the waiting time of people as well as their travel time in the network, then you combine A1 and A2, and therefore we can have multiple objective optimization for the evacuation problem. About the demand estimation, this is just a snapshot for people who were present in the city of Toronto using their cars at different time of day. This is a cumulative number of people. So at 6 a.m., as you can see, there is not much activity with so many cars in the network. When you evolve with time until 9 and noon, you find more black cells, which means that this is the number of people located at different evacuation zones. And we have different figures like these ones for people who have transit and so on. And it turned out that the worst case scenario for evacuating the city of Toronto is going to be at noon, which is the worst case scenario. This is the city of Toronto, as you can see here. If you haven't been to the city of Toronto, this is where the CN Tower is located. You have to see it if you have a chance. And city of Toronto, it's 2.37 million people. And the area, as you can see here, is quite massive in terms of evacuation. So the framework, or actually the application, was to evacuate the entire city of Toronto in case of any disaster. So having said that, we have to have a representation for the road as well as the transit networks. And as you can see, they are exactly replicating the high resolution satellite image. The one on your left is the transit network. The one on your right is the road network. And in the transit network, we are dealing with almost 1,300 buses, shuttle buses in case of emergency evacuation, and 4 metro lines. After doing the optimization for such multimodal evacuation framework, we kind of get down the average evacuation time from 7 hours to 2 hours, which is actually the combination of the waiting time plus the travel time. The network clearance time, which is the time at which the last one leaves the network, getting down from 30 hours to 9 hours, which is almost 75% improvement. And the average stop time, which is a replication for how congested is the network, down from 6 hours to 0.5 hours. And as you can see at the bottom, these are the associated loading and evacuation curves that I referred to in the few slides before that. And as you can see, the area between the two curves is kind of minimal in case of the optimal plan and shifted to the left. This means also that we are minimizing the waiting time as opposed to the figure on your right in here. Also, this framework was built with a vision in mind that we need to have it implemented in real time. And in order to do so, one optimization for this work takes almost 90 hours, which is almost 3 days. So we thought about having a high-performance computing facility that does the optimization job. And using this number of CPUs, as you can see, we almost get a linear speed up on how the optimization problem can be solved. So getting to the transit part, we have, through the demand estimation model, we can see where people are located. And then also we have an estimate for where buses are located at the onset of the evacuation, which is turned out to be at noon. And then through the optimization framework, we get a detailed routing plan and schedule for each bus. So this figure shows here that this bus picks up some evacuees from certain point and then delivers them to another certain destination, and so on and so forth. So in conclusion, we found that it is very essential to have an estimation for the demand in case of emergency evacuation by mode and by time of day. By mode in order to address all people who are captive to certain transit modes. People might not have access to cars or at all during evacuation or at all, as well as by time of day to mimic or to actually represent what is the worst case scenario. Also, it is very essential to consider waiting time at origins. This is especially important for people who are captive to transit. It is also very essential to consider the readily available transit system capacity. All these buses and subways that you have, it is very important to get used in emergency evacuation. Talking about some numbers in summary, for the automobile evacuation in Toronto, as I mentioned, we get the average automobile evacuation time from 8 hours to 2 hours. The network clearance time down from 30 hours to 8 hours. The average stop time from 6 hours to 0.5 hours. And the average in-vehicle travel time from 7 hours to 1 hour. Looking at the transit shuttling problem, the average transit evacuation time was 2.5 hours. The network clearance time was found to be 4 hours. And using the high-performance computing facility, we get down the computational time from 90 hours, which is 3+ days, down to 1.2 hours, which make it applicable in case of real-time implementation. And also, this framework was built in a vision to have it available not only a dissertation that's going to be set on the shelf, through the so-called UITS. UITS is online network enabling intelligent transportation systems, a framework that is built using the Web 2 technology in order to have information sharing and data and resources as such a framework to be accessible to research institutions. And I do have some flyers here at the end for UITS as well as for the emergency evacuation work that we have. And also there is a poster in Hall 2, in Hall 1, that explains more in detail the emergency evacuation framework. With that, I will conclude, and thank you so much.
Thank you, Hossam, also for your time discipline. I think a very important contribution to the safety and security discussion we have on all levels. When I think of how long it takes to empty a stadium and how long it takes to empty now a whole city and how urgent it is in these events, it is a meaningful contribution to solving the problems involved. I just wonder whether your approach would also apply to the situation in Cairo with other restrictions to consider. We have hardly any time to discuss, unfortunately, but I will, after each presentation, allow questions and remarks, one round only. I will collect, that's the only one. I close the list of questions, please.
Thank you, Mark. Oh, it's on. Okay, so my name is Matthew White from the UK Department for Transport. I had a question because I actually read this paper because I was actually on the panel that assessed it, and it's quite interesting and very informative. But I did wonder, I don't remember any reference to people who might be injured or people who had mobility problems or anything like that. It seems to me likely that there'd be quite a high number of these people in many disaster situations. So have you considered that?
Do you hear me? Okay, well, I didn't get the question. I didn't hear it well, but from what I hear, is it basically about people who have certain disabilities? Okay, well, this framework actually addresses people who have, the whole population who have their cars or they have any other mode, like transit. Most of the transit modes in Toronto, like buses, the TC buses, the Toronto Transit Commission, have lower floor that could be getting down to the platform in order to get these people who have some disabilities. However, at this level, we didn't get to the very fine level of detail of identifying where those people are located. However, they are included on the numbers that you see in here. But there is no explicit representation or actually mentioning of where those people are and how many of them.
Okay, thank you. As you can see, oh no, you can't see yet. We will rush from Toronto to Madrid. And I'm happy that we have Javier Aldecoa here among us. He is an architect and a master of ergonomics and psychosociology. Whatever that is, I hope you don't explain that to us in your presentation. He is the director of intermodality and concessions of public works with the Madrid Regional Public Transport Authority. And he will talk on the Madrid Transport Interchange Plan. And with this project, he was not only the finalist, he was the winner of the ITF UITP Prize on Outstanding Innovations for Public Transport. Congratulations, both of you, of course.
Okay, thank you, Axel, and thank you to the ITF and to the UITP for permitting to explain to me what's going on in the region of Madrid about innovation in the Madrid Transport Interchange network. Now, at this moment, we are living certain revolutionary problems about the transport network in Europe. But in extreme situations is when users check the weaknesses in the operation of a public transport network. The crisis caused by the eruption of the volcano in Iceland has been a good reflection of the weaknesses of the public transport system in Europe. Of course, one must start from the premise that a network can be dimensioned for the limiting minimum level of quality service without involving large cost overruns in the operation and daily maintenance. This extreme situation has to be extrapolated to regional public transport networks that may arise in transport interchange at a particular time. Rail, bus and shipping operators increased their services during the closure of the European airspace by the eruption of the volcano to bridge, as far as possible, the confusion which reigned among users across Europe. But the question we must ask in this transport is this. Transport networks has the minimum intermodality to give proper services in the event of extreme situations? In those cases, we must be able to change the red light that appears when all the airspace was closed to a green one, improving the information transfer security and management in the overall transport network. Transport interchanges are a crucial part of the public transport system that allow users to carry a wide range of travel in a comfortable and enjoyable situation. Recently, it has been shown that the ancient concept of train station, bus station, or airports is no longer valid today. Mobility presents complex patterns, and commuter trips are increasingly coast farther away and include, therefore, a greater number of stages. It is very important, therefore, make the public transport user journey as a unit and to reduce the sense of displacement involving rupture of the transfers. The ideal of public transport in order to compete on equal terms with a private vehicle is that the user can perform their door-to-door travel and reduce the travel time of the journey. Transport interchanges are accompanying infrastructure and therefore should be placed where there is such a need, whether surface or whether underground. Transport interchanges design is undergoing major and important changes in recent years. Users are demanding better quality conditions in the development of their transfers, as important or more than those who already enjoy the occasional trips by plane or by a high-speed rail. These new demands require increasing the quality of service provided and, more importantly, perceived quality in this type of infrastructures. Transport interchange stations are a crucial part of the public transport system, which allows travelers to make a wide range of trips, both comfortably and pleasantly. It's more and more evident that modal integration plays a fundamental role in the transport system's success. The fact that more citizens have abandoned private transport to use these interchange nodes serves as proof that the old concept of railway and public bus stations is no longer valid in today's world. Madrid Interchange Plan is the culmination of this unification process between the interchange points of the regional bus lines and the Madrid circular metro line that you can see in this graphic. With the adequate construction and improvement of the new transport interchange stations, a modal interchange network has been organized around Madrid's entrances in relation to the highways that access to the city and the circular underground metro line. Madrid region has 7 important highways that you can see here represented by different colors that connect the region with Madrid city. In each entrance, we have built up an interchange station connected with the metro underground network for the regional and for the urban bus lines. Here I show one of the examples that we have built up. In any case, it's an extremely ambitious plan, not existing anything like it in any city in the world. In other cities, they have been able to build one interchange station, but none has built a network of interchange stations that can move more than 1 million users a day and containing the entire flow of passengers accessing the city from all of its entries. This example of a Plaza Ellíptica transport interchange station was to build a new underground transport interchange station that would optimize the connection with metro lines number 6 and number 11 for close to 60,000 users of metropolitan buses, particularly once the latter line extended into the city center. This would result in the removal of street-level interurban bus services, complete the reorganization program of all the interurban bus terminals around the circular metro line, and improve the waiting and bus changing experiences of bus users. This Interchange of Plaza Elliptica is divided in 3 different levels. The first 2 host the 20 intercity bus bays, and the underground level, the last one, connect with the metro station. Madrid transport interchange stations are an example of innovation and a global benchmark, being the model exposed in most of transport conferences for broadcast. In order to guarantee the functional viability of the transport interchange stations, a system is required to supply the stations with data and information efficiently and responsibly. This system should provide the user with a comfortable environment where they appreciate the safety, rapidity, and integration of all the transport available through clear, intuitive, and efficient information. Also, an automatic vehicle location inside the interchanges has been developed in order to locate the buses in those underground places where the GPS doesn't work. You can think that this is, for us, is a very important issue because all the GPS, when the buses enter in these stations, we lose the signal, so we can know, it's impossible to know where the buses are located. Also, we have developed a bus control occupancy base in order to permit the access of the users to the bus only when the bus is on the bay. Otherwise, the user can't open the doors bay. Also, it's necessary to have a complete passenger expedition control that permit a better planning and management of the bus services. Safety is one of the most important pillars of any transport infrastructure. And this is particularly true of transport interchange stations, which are used on a daily basis by hundreds of thousands of passengers. The design of the installation is based on a fundamental requirement that we have established in all of these type of stations. We have to limit the evacuation time to 6 minutes, sufficient time for those in the building to evacuate and be in a safe external space. This requires that the study specifically deal with all the fire safety criteria used as a basis for the development of current regulations. As a result of the mobility and fluid dynamic technique simulator studies, it was possible to verify the designs, the operational plans, and the evacuation times, and the conditions for the transport interchange stations, making this infrastructure safer and more comfortable for passengers. This is a very brief situation of what we are going on with the transport interchange network in Madrid, but as I said in the beginning, I think that it's very important to have an important network of interchange, not only in the regional geographical area, but also in the national and in the European, because we cannot permit that when one volcano became to do problems with the airspace, we can have a lot of citizens that were with any possibility to take other transport mode. Thank you very much.
Thank you, Javier. We learned yesterday how important intermodal or multimodal trip making is. I assume there is a huge potential for CO2 reduction or modal shift to public transportation. And the better the situation is for the trip makers to cut their complex travel time, which includes waiting times and times for transferring, the better the service is. So also a very important contribution. Any questions and remarks, please? More? Just one. Fine. Please.
Is it working? Jérôme Pourbet from the UITP. Thank you very much for your presentation. Could you tell us some words about the financing of those interchanges? But I think the financing also is quite innovative in its principle.
Well, all the financing, of course, this idea of the interchange network that we developed in Madrid was or became in 1997 with the first one that was Avenida America station, and the idea was that with all these interchanges, because of we built up also different tunnels in which we can reduce the time of the travel, the operators obtain a benefit because of this reduction, because they can use less buses for having the same services, and also they have a big issue that they usually in the first year they have an increase of the 20% in the demand. So what we thought 10 years ago that it was necessary and it was a good idea to put a tax that the operator has to pay per each user that goes to the interchange or goes out from the interchange. In this sense, we could offer this model of interchange, of transport interchange to the market, and we obtained some private companies that were interested in this model, and we use the concession, the public concession for building them. So in order that the companies have to pay with private money, they have to build up these interchanges, and they have to return back to the administration in 35 years. And they have to pay the operators, the private operators that carry on with the bus lines, they have to pay a tax to these private concessions. This is the general idea. Of course, you have certain interchanges that are more profitable than other ones, but this is like in all the concessions. But of course, this tax that we implement is not the same in one or in other ones. Okay, it depends on the benefit that the operators obtain with the reduction in their timetables and with the increase of the demand.
Thank you very much. Okay, we continue. Our virtual journey goes on to the city of Ahmedabad, 6 million inhabitants in India. And I have the pleasure to welcome Mr. Gautam. He is a very experienced municipal commissioner in this town. He has served on many levels as a public administrator and started with the Indian Revenue Service as an assistant of the commissioner. In the following years, he was occupied with energy questions, with power question. He was director of finance, and since 2006, he is a commissioner in Ahmedabad. But here in this town, he spearheaded the bus rapid system program, and with this work, they were finalists in the ITF UITP Prize on Outstanding Innovation for Public Transport. Please.
Thank you. I would like to make a video presentation first. Please start.
So we start with a movie.
There's something about the city. Its crispness that extends from dawn to dusk. Its vibrancy that lingers on into the stillness of the night. Its silence that's eloquent. its vocabulary that's awe-inspiring, its soul that reflects a rare consciousness of the global environmental challenges, and the responsiveness with which it has converted over 65,000 auto rickshaws to CNG from 2005 to 2009, augmented its fleet of buses from 560 to 1,010 in just 4 years, replaced its aged and diesel-driven public transport vehicles with Euro 3 compliant CNG buses, improved its road network and completed the missing links, built new flyovers, river bridges, ROBs and underpasses, and in the process emerged as an environment-friendly city. This is Ahmedabad, a city with consciousness. Spread over 466 square kilometers, Ahmedabad, the 7th largest city of India, is a compact city with high density and diversified land usage. It is a throbbing urban center that binds mixed income groups into one socio-cultural fabric. 6 million people, 2.2 million registered vehicles, 2,398 kilometers of road network. Yet its annual road fatalities are amongst the lowest in the country. And to top it all up, this safe city has embarked upon yet another pioneering idea, Janmarg BRTS. Janmarg, which literally means People's Way, is a citizen-centric initiative for moving people and not on individual vehicles. It is a one-of-its-kind rapid transit system for enabling citizens to travel in a safe and secure mode that's reliable, affordable, convenient and comfortable. Janmarg BRTS is not just a corridor, but a scalable network. It is not an isolated project, but a comprehensive program to empower people. It is not about creating a public transport infrastructure, but a core part of an integrated strategy to enhance the quality of commuting. The 89-kilometer Janmarg BRTS network would connect the railway station and the central city with outlying industrial, institutional and residential areas. However, the most significant feature of the system is that the network passes through over 80% of lower and middle income household areas. The first phase of 12.5 kilometers has already been implemented, and additionally, another 5.5 kilometers of network was added on a war footing to facilitate connectivity with Kankaria Lake, Ahmedabad's most happening public space, while another 8 kilometers has been made functional, connecting the industrial area of Narol to the network, taking the total coverage to 26 kilometers. Little wonder that in just over 6 months, the BRTS has evolved into a lifeline of Ahmedabad. A lifeline comprising elements that are world-class and state-of-the-art. Peak hour frequency of 4 minutes between buses. 2 median bus lanes. Split flyovers. Tree-lined corridors. Roadside resting benches. Dedicated cycle tracks. Dedicated service lanes. Dedicated and well-lit pedestrian paths. Swanky bus stations with sensor-driven automatic doors. High-floor Euro 3 certified 80-passenger capacity buses. Specially designed buses with 2 wide central doors. Perfect docking alignment for easy boarding and alighting. Convenient access for the visually and physically challenged. Off-board smart ticketing. Smart card validator. Smart cards for frequent commuters. Special cards for senior citizens, students and visually challenged. Electronic passenger information system. LED panels and public announcement systems.
Next Janmarg station is Anjali.
GPS console for real-time tracking of bus movements. color-coded special uniforms for BRTS staff, full-fledged driver and staff training and assessment programs, immaculately trained and service-oriented drivers, state-of-the-art control center, and extensive use of IT applications for automatic vehicle tracking and monitoring, high-tech surveillance, operation control, real-time passenger information system, traffic management, electronic fare collection. Yet another unique facet of the system is a public-private partnership model for a wide array of functions, including pay and park facilities, bus ownership and operations, fare collection, landscape development, and even bus station cleaning and maintenance. Genmarg BRTS is being implemented by the Ahmedabad Municipal Corporation and is well supported by several other agencies such as ORDA, GIDP, City Traffic Police, and the Department of Urban Development, Government of Gujarat, and the Government of India under the JNNURM. And what's clearly evident is a new and professional management culture that has seeped in solely due to the creation of the Ahmedabad Genmarg Limited, a special purpose vehicle and a dedicated company to manage and operate the BRTS. However, what essentially lends the entire system a touch of class is the fact that CEPT University Ahmedabad is the principal consultant for this project. In fact, implementation of Genmarg BRTS has also led to the establishment of a Centre of Excellence at CEPT University, which has now introduced a master's degree program in urban transportation management and planning. In addition to this, the lessons learned from the Bogota model have gone a long way in making BRTS a model initiative for other states of India. With approximately 7 million people having used the BRTS in the last 6 months and a daily average load of over 50,000 passengers, this immaculately planned and impeccably implemented system has set new benchmarks in public transit in South Asia with its wide-ranging benefits that are clearly evident and quantifiable. Improved air quality, acceptance of the system by all sections of the society, better traffic behavior, safer streets, appreciation of the system by international experts, 52% modal shift from private vehicles to public transportation, 95% increase in ridership in just 6 months, and above all, 100% enhanced quality of commuting. Reasons why, apart from receiving the award for Best Mass Transit System in the country from the Government of India, the Genmarg BRTS has also earned global recognition by winning the 2010 Sustainable Transport Award. This is the first time in the 6-year history of Sustainable Transport Award that a developing nation has won the award. This is also the first time that an Indian city has won the award. And Ahmedabad has joined the elite group of cities, past award winners such as Bogota, Seoul, Guayaquil, Paris, London, and New York. Genmarg BRTS continues to play its role to perfection, the role of a lifetime. Genmarg BRTS, the lifeline of Ahmedabad.
As this video presentation was shown to you, most of the information given in the presentation I do not want to repeat. For success of any transport system, the dependability and reliability is one of the most important factors. Unless the transport system is dependable and the time schedule is maintained well, nobody would like to shift from the private vehicle to public vehicle. And this was the problem in our city, especially in Ahmedabad. Ridership of our public transport system has gone almost 20%. From 16 lakhs, we have gone to 3-4 lakhs. Lakhs means, and now we are running a public transport system. Around 1 million people are using that, apart from this BRTS. The main feature I would like to mention here that we had copied in beginning the Bogota model, but we have made many changes according to our need of the Indian cities, Indian culture, and the population, because our main city area is 200 square kilometer and population is more than 5 million, and rest 300 square kilometer population is 1 million. The basic problem is that people, those who are staying outside the city, all 100% they are using cars, maybe 4 cars in one family. Our basic motto is that how to stop them, that they should not bring their cars to the city center. This I will come. This you have seen. This is the boundary of municipal corporation. But this is the area, more than 70% population is staying. The people stay in that particular area are bringing more than 5 lakhs car every day in that side. We have 2 million cars, more than 2 million, maybe 1 million cars and 1 million, and more than 1 million two-wheelers and three-wheelers. What we have done, we have connected this ring road with all parking lots here, big parking lots, all 4 directions, so that the people coming, these bungalows, big bungalows, they should not come to city center. They should use this parking lot and then come to city center. Use this whole, this is the command area. And we are also running our feeder bus services. This particular system is running for last 6 months, and we are hopeful that we are completing 89 kilometer within, another 30 kilometer within 3 months, and another 40 kilometer within 1 year. The basic, the PPP model, this infrastructure is developed by, infrastructure is created by us, but the bus operation, maintenance, this with the PPP, including ITS, collection of fares, maintenance, cleaning, and everything. Second very important feature in this particular, because you are running buses, these are the roads, we are running in buses both the sides. First time we have taken 8 meters mid road from the people. These, if you see this is the, sorry, this whole road, now we have taken this much, this you can see 8 meters. It's very difficult in a city. That's why a consultation, a continuous consultation with the people, citizens, where and fortunately they have accepted the system, and now the system is no longer owned by Ahmedabad Municipal Corporation or Ahmedabad Janmarg Limited, but it's owned by citizen of Ahmedabad. It's owned by people of Ahmedabad. That is the basic and very important feature in this particular thing. This transport system has been developed. We have AMTS, traditional city bus services. We have auto rickshaws. We are coming with the, we have planned to bring regional rail. We are also working for metro and this BRTS. But in this planning aspect itself, we have taken that all 5-6 modes should be coordinated in such a manner that one ticket is, common ticket could be used. And we have taken, when we have taken plans, this, we have not gone to metro road. Metro road is coming like this. Then we have not taken that particular area. Like this the railway lines. This is going to be used by regional rail. That we have left, and we will work for feeder. We will work like a feeder for metro or regional rail, another system. And there could be a common ticket for everyone, and we are working on that direction. But that is more important, because once you are bringing any new transport system, the unions, the organizations, those who are working, those who are having businesses, they are the people, those who are going to attempt for failure, or they have their own pressure group. But in this particular system, we have tried that everybody should be kept aside, and they should come also together as far as ticketing and fare collections are concerned. So these are the few features, and this basically we are the first city in India, second city. First was done by Delhi. We had 55,000 auto rickshaws, which were diesel driven, diesel or petrol. We have converted into CNG, compressed natural gas. Thousands and thousands buses are changed, and we were known as a polluted city. In India, our number was around 3-4 as one of the most polluted city. We are from first, second, third. We are third in 2004-5. Today we are 68, 60, 65, then 68, and we are trying that it should be more than 100. We should improve our environment, because more than 2 million cars and this, every day it's coming. It's creating more and more problem from environment. We are trying that all this ring road should be, this all bungalows, and this more than 500,000 people are having cars in that particular area. 500,000 cars are there in this area, and this area, and this area. We want that it should not come in city. And that's why we have given one of the most dependable and most reliable transport system. The name is Janmarg Limited. Ahmedabad Janmarg. This is all. I don't want to go in details, because most of people are, these were the roads earlier, before we entered in this particular, now this road is like this. We have changed this, now it's this. That changes we brought in last 2.5 years. We started this project in 2007, completed in 2009, because completion of the project within time frame is very important. If you are not, then people will not wait for longer, and they will go for another parallel modes. These parallel modes are going to more and more dangerous for environment. I don't want to go in all the details. These are the certain photographs, features. It's available in the, these are collection.
Thank you.
Yes, thank you very much. I think I've kept my promise.
Yes, almost. I think a terrific achievement for your town. Ahmedabad can be very proud, and I'm very happy that we have the mayor.
Mayor, Mr. Kanaji Bhai Thakur,
Okay.
is present. Just 1 minute I can put a card. Just please.
Well, we run out of time, though.
1 minute. 1 minute.
Okay.
Just because.
One.
He's our mayor. We have come together. Just I want.
If you allow your system to run late.
Sorry for that.
Okay, I thought you wanted to say something.
Just nothing.
Okay. Any questions? Further questions? No, just 1 and 2. Okay.
You mentioned, Eric Sampson, Newcastle University, UK. You mentioned that you had a very bad problem with cars coming into the city, and you wanted to do something about it. Have you considered a London-style congestion charge which will attack the problem and raise revenue?
You got it?
No.
Whether you considered the congestion charge like London?
No, sir, not right now, because people are cooperating us, and we are trying that they should not come with their vehicles. They should keep in parking lots. We are creating parking lot, we are connecting with the feeder buses, we are connecting. Because this negative approach may not help all the time. And in our city, we have failed in past. I don't want to go for this. And our mayor will also agree with me. We are trying that they should be given proper facility, that they should not come. We have connected with BRTS, we are connecting with metro, we are giving them public transport, and we are saying that you should not bring your vehicles. You made them impossible that they should bring. First, you give today we do not have given any facility. If you are going to penalize them, then they will come forward for fighting and all that. Better first you give facility, then you go for this congestion. This is not right time for us. It may take another 5 years.
Okay, Professor May.
Thank you. Tony May, University of Leeds. Again, congratulations for what you've achieved. We've heard a lot in this conference about the Delhi Metro. I wonder if you could comment on the size of city in Indian conditions which justifies a metro and the situations in which a BRT is justified.
You got it? No. What would be a size of an Indian city where you would prefer a metro system to?
Ahmedabad is not that appropriate size for metro. Frankly speaking. But our capital city is Gandhinagar. It's almost 20 kilometers away. That is why it's from 2005 onward, we are trying that there should be a metro. But first we have implemented BRTS. We are going for metro slightly later stage. Since I have worked in municipal corporation for 4 years, and as per my experience, there should not be metro if the population is less than 1 million. If we have other modes, because it's very costly as far as India is concerned, and break-even is not possible unless you are going for a subsidy. If you have a lot of money to give a subsidy, no problem, you can go for metro for even 500,000. But it's in the design. Suppose metro is coming after 5 years, 10 years, we should not crisscross. We should supplement and complement each other. This is our planning. Thank you.
Thank you very much. We stay with the issue bus rapid transit system, and for that we have to rush back to Europe. We go to England, and I welcome David George. He's a civil engineer and worked for several years in the public and private sector, always in North Kent. And then in 1995, he started for the traffic director for London and designed and implemented the red routes and bus priority measures. Since 1999, he is the fast-track project manager and works for the Kent County Council. Already in 2008, he was the project leader of the year and got an award for that, award of the inaugurated passenger transport management. And in 2010, he was one of the finalists of the ITF UITP Prize on Outstanding Innovation for Public Transport. Please, David.
Good evening. I'd like to thank ITF and UITP for this opportunity to present Fast Track to you, and with a particular focus on the innovation behind the project. I should stress, I think, at the outset that the Fast Track project is located in an area that's very, very different in terms of scale to what we've heard already. Much, much smaller than the city size and even international transport that we've been talking about this forum, and much smaller than Janmarg, as we've just heard. But we do have in common the words bus rapid transit, I think. A relatively small area then, but very significant in UK terms, with round about £2 billion worth of regeneration investment planned. And we're using an innovative approach, using public transport to deliver that regeneration in a sustainable way. Where are we? In an area called Kent Thameside, located in the southeast corner of England, as you'll see on the map there. This map shows in the orange area an area called the Thames Gateway Regeneration Area, which is a major UK regeneration initiative to deliver much needed area alongside the River Thames in the Thames Gateway area. Focusing a bit more, you can just about see, I think, the Kent Thameside area just on the edge of London there. You can see the road and rail connections down to the Channel Tunnel rail link and the high-speed line. And we will have in the Kent Thameside area we have an international station on the high-speed line, and that will be a gateway station for the 2012 Olympics when they're held in London. Facing in a bit more into the Kent Thameside area, it comprises the towns of Dartford and Gravesend and the area in between. Very small, as I say. Probably on this map you're looking at somewhere around about 60 square kilometres in total, with a population at the moment of around about 190,000, obviously very small by city standards. But the important thing for this area is the yellow blobs, if you like, on this map. These are the major development sites in the area where up to 30,000 new homes and 50,000 new jobs are planned, and by 2026 there will have been a 25% increase in the population. And the fast-track network, shown in the pink dotted lines on this map, is intended to join those new developments, the existing towns, the local railway stations, and particularly the international station at Ebbsfleet. Here's an aerial picture of the heart of the area, an area called Ebbsfleet Valley, largest single regeneration site in the area. This picture was taken about 2 years ago, and here is a picture of the master plan for this area when it's fully developed in about 15 years' time. With 10,000 new homes and 20,000 new jobs created it. On the left of the picture are a series of urban villages, homes, schools, shopping and leisure facilities, and on the right, clustered around the international station, is a major business district. So we have policies to get homes, schools, leisure facilities, but also employment opportunities very close together on the same site to reduce the need to travel at the outset. And the idea of Fast Track, as I've said, is to join this up with a direct, attractive and credible alternative for using the private car for local journeys. Currently there are 2 Fast Track lines operating, total of 25 kilometres and carrying 2 million passengers a year. Our transport modelling shows that when the area is fully developed out in about 2026-2030 time, we will need to be carrying around 30 million passengers a year, so a huge step change even above to what we've got at the moment, with a network of some 40 kilometres in total. So then what's particularly innovative about Fast Track, apart from having the things that some of the things you've seen on JamMag on a smaller scale, 50% of the network already dedicated busways or bus lanes, and a very high level of priority and integration with other transport modes. Everything you'd really expect from a BRT scheme or an emerging BRT scheme, certainly. But the particularly innovative features of Fast Track, firstly, it's firmly embedded in spatial planning of the Kent Thameside area. Since as far back as 1995, the vision for the area was set out, and it was really identified that a major shift would be needed to accommodate all this development in the area, a major shift away from the private car onto public transport. And following the original vision, there was extensive transport modelling, and studies showed that we could achieve this, but only if we achieved this major shift to public transport. And originally, a tram was proposed for the area, but to cut a very long story short, and you'll understand why, affordability, scale, flexibility, etc., ruled out a tram. But we discovered that we could achieve our objectives with a bus rapid transit system. And all of this was clearly set out and articulated in policies, from visioning into the spatial planning, the local authorities and planning authorities documents, clearly articulated to stakeholders at all levels and indeed to the general public to get buy-in at all levels into this project. Bus legislation in the UK is, shall we say, challenging. The majority of bus services are operated on a commercial basis. That is, if they don't make money, they don't run. What we were trying to do was insert a new bus rapid transit system over the top of a sustainable commercial bus network, but well ahead of the new passengers that were going to come along to make it commercial. From an operator's point of view, suicide. That was the challenge we faced, and I could go on all day, but I won't. You'll be pleased to hear, and bore you silly about how we did it, but we managed to achieve this. Was quite a unique and innovative way, working with government departments and our operating colleagues to make this work. And partnership is often an overused word, but our partnership between the County Council and Arriva developed and matured during the planning phases and has resulted in a really proactive and can-do approach that's delivered a very high-quality service and already a step change in local bus service operation. But of course, any public transport system is only as good as the passengers perceive it to be, and we invested a lot of time and effort, though not very much money, I have to say, in building a successful fast-track brand. And after 6 months, passengers were already referring regularly to travelling on fast-track rather than on a bus. And fast-track has enjoyed very high levels of customer satisfaction since. Very quickly, I just want to say it's all fine and great to have policies in place, but it's what happens when you get on the ground, the reality of putting them in. And I just want to very briefly talk about the bridge development. Relatively small, even in Kent Thameside terms, 1,500 homes. But this is the master plan of it. You'll see the homes clustered down the left-hand side here, the western end of the site. Employment opportunities up here on the right-hand side. And the leisure facilities, shopping, community facilities in the centre here. But the key thing is the whole development is master planned and built around fast track as the spine right the way through it, reserved exclusively for fast track. Here's an aerial view of the site taken about 18 months ago. You can see here the first houses were just under construction then. Some of the employment opportunities, logistics were also being constructed then. And that was the route of the fast track going through it. Interestingly and innovatively, the fast-track route was in, with the developer investing around £20 million, up and running to its full frequency before a single person moved into a house or a single employment shed was occupied. And the £20 million from the investor included an £8 million bridge across the M25 London orbital motorway here. Here's another picture of it just here and across here, which provides a great access just for fast track that misses out congestion on the motorway at a close-by junction. And the infrastructure on the busway through the development is to a very high quality indeed. Not only that, but the developer has paid for all of this infrastructure and procures the service from operator Arriva for a 17-year period. Contrast that with the normal UK support for a bus service that lasts at most a year, and you'll see that this is a very innovative and forward-looking agreement and arrangement with a developer. And each resident of this development is provided with a smart card, giving them free travel on fast track. And each house has an electronic information screen built into it, either in the hallway or the kitchen, that provides a whole range of electronic information, but primarily real-time information about the fast-track services. And the resident can set an alarm that tells them when they need to leave the house to walk the less than 5 minutes to the fast-track stop for a service that is less than every 10 minutes and for which they do not have to pay. Add all this together, and the bridge is a showcase of public transport measures designed to attract residents to public transport rather than unnecessary use of a private car. Is it working as it was intended? Well, yes. Anecdotal feedback so far from residents says it is, and you will hear that in just a moment in a short video I have. However, the recent adverse economic conditions undoubtedly have curtailed house building, so the jury is still out really, and we're not really in a position yet to work out measurable, clear trends. But so far, so good. So that was a very brief overview of what we're trying to do, picking up on some of the things, giving an insight into the innovative approach we have taken with Fast Track. It's a very complex project, and I've only been able to sort of just scoot over the highlights. You'll see up here on the screen what our aim is, what our objective is. All of this needs to go in early. That's a fundamental policy approach. Goes in early so we can influence the residents' travel behaviour before they start using a car, to give them a credible and attractive alternative. And the success of Fast Track over the last 4 years gives us a real good starting point for the future. There's an awful lot more and a lot more innovation to come. And I'm going to play a short video now, but if you'd like to know a bit more, there's more on the website. There is a flyer at the back where you can pick up to find out more information about that. I will attempt to get this video working now.
To reduce future congestion and ensure that the regeneration of Kent Thameside is sustainable, a 21st century approach to public transport is crucial, which is why Kent County Council, along with the public and private organisations that make up the Kent Thameside Regeneration Partnership, has developed Fast Track. Fast Track takes the best features of light railway and tram systems, convenience, frequency and reliability, and applies them to existing bus technology. This creates a rapid transit system that operates and feels very different from conventional buses. The focus is on quality, convenience and reliability, a credible and attractive alternative to the car for local journeys. Launched in 2006, the first phases of Fast Track have been a huge success. Already around 2 million passengers a year are using the service, but this figure is predicted to grow at least tenfold as future major developments, especially Ebbsfleet Valley, come on stream, expanding the network. Most importantly, nearly 20% of passengers have said they would previously have used a car for their trip. So what makes Fast Track so attractive? Dedicated traffic-free bus lanes with priority at junctions. Comfortable and spacious, high-quality, low-emission buses. High-quality stations and waiting areas. Convenient real-time passenger information systems, off-bus ticketing, all wrapped up in a distinctive brand. No wonder Fast Track has become so popular with its passengers and won so many awards.
As a mum, I do use it. I use it 6 times a day to take my children to school because my little girl's at nursery. So, I mean, I'm backwards and forwards to school and that, and they love it getting on the bus. They put their hand out to stop the driver and they think it's good. They love sitting up at the front with them, right by the bus driver, so they know.
Fast Track's really changed the way I travel because now I don't need to take my car into town if I'm going into shop, which means I don't have to find a car parking space, which saves me at least 50p every time.
I think the one thing I've seen this year, going up, the cost of petrol got so expensive, so it's really helped us out with the budgeting, and we're not spending as much money repairing the car. We managed to sell another car and that saved us some money, put some money towards, we had a nice holiday from the funds there, so it was great being able to do that.
Currently, 2 Fast Track routes serve existing communities in Dartford and Gravesend, and newer residents at the bridge, as well as providing connections to Bluewater and Ebbsfleet International for onward high-speed rail travel. Over time, Fast Track will grow to link all the new developments in the area, including Ebbsfleet Valley and Northfleet Embankment. Fast Track. Convenient, reliable, attractive. A vital part of Kent Thameside's sustainable future.
As someone once said to me earlier today in the forum, all transport is ultimately about people. And it's good to hear that people like your transport system, isn't it? Thank you.
Yeah, thank you, David, for your presentation. Like Amdeba, we also have to congratulate your region that you apparently have found a cost-effective system. And I ask myself whether we have to face a new phase after the renaissance of the streetcars, whether we will maybe face in certain areas a renaissance of sophisticated, cost-efficient bus systems. Any questions? One? Further questions? One question here, first row.
My name is Beher Abdulhai from University of Toronto, Canada. In Toronto, the government is adopting a policy to densify the downtown core, bring people from outside the city to dwell in the city so they can serve them by public transit. But at the same time, they are contemplating congestion charge similar to the London initiative. And I'm wondering, would that reverse the densification process and people and businesses would migrate from the city to the suburbs? So I'm wondering if you're aware of any reverse migration out of London, maybe to Kent, and whether the increase in residents and activity in Kent is, at least in part, caused by the London congestion charge.
I think it's the geography of the area is such that most of the travel into London is by rail anyway, and historically has been. And indeed, with the high-speed line now from Ebbsfleet Station in the heart here, the journey time into London has changed from just under an hour to 17 minutes. So rail is even more attractive now into London. So the congestion charge really has little impact on the area where we are. In fact, what we're looking to try and promote is the reverse commuting out from the London suburbs out to the Kent-Thameside area. And we're looking for an international company or a headquarters to base themselves in the area. If there's anyone in the room who's got any contacts, I'm going to see them afterwards. To actually establish the business district there, to attract people to commute the other way, actually.
Yeah, thank you very much. Ladies and gentlemen, we come to the grand finale. We come to a true inventor, a non-professional who has almost professional ideas, or true professional ideas. I'm happy to introduce you to Juwan Yoo from Korea. He loves to write programs on the computer, and with this passion, he developed the iPhone Seoul Bus application. This deals with public transportation websites to provide real-time updates of bus arrival times for all bus stops in Seoul and its surrounding provinces. Please, we are very curious.
Would you please black this screen for a while? This is not the first slide, so I have to move out. This is not the first slides. You have to go here. Okay. Oh, hi. It is my honor to be here and give you a speak, and I cannot forget this moment for the rest of my life. Okay. I developed the iPhone application named Seoul Bus, and this application is providing the information of the buses of the Seoul city, and this is the Seoul city, and its nearby city like Incheon city and Gyeonggi province, and it provides these areas bus information. And I want to show you the demo first to show you what it has functioned. So the Seoul Bus first, you can search the bus to look up the information of the bus. You launch the application, and you can tap number to search. And here comes the general information about the bus, like the service hours and like that. And you can tap the route information to show where the bus will go. And in the right side, you can see the position of the buses, and it's also the real-time data. And you tap it to see the bus stop information, and you can see what bus is going through and how much time left to that bus comes. And you tap it to see the further information. You can see that this bus will come in 1 minute, and it's like that. And also you can search the stops by its bus stop's name, and all of the bus stop in Korea has its own unique number and 5 digits, so you can type that 5-digit number to search it, and here comes the stop. And you tap it to see the information, and it just like you would see before, just before. It shows what bus is going through and when the bus will come. And this nearby stops features show you the nearby stop using the GPS sensor of the iPhone. So, and you can also see it in the map view, and that pins shows that where the bus stop is, and also this view is provided. Okay, and the last feature is bookmark feature, and you can add a bus and stop and also the arrival information of the bus to the bookmark to access quicker, and tap the bookmark button and you can customize its name to you can easily recognize. And I take that bus to go to school, so I named that bus to school. And you can search the bus stop to add, and it's just the same. And by the way, the background video is the Seoul's most popular street named Gangnam Station Street. And okay, you can add the bus stop to the bookmark, and also there's arrival information to the bookmark for fast access. And after typing it, and always take a long time. Yeah, after adding a bookmark, then you can fastly access to the information. After you shut down that application and relaunch it, then you tap it and it loads fast, so you can get to the information as fast as you can. Okay, I think we saw all the features, so we can skip it through the. Okay, and with this application, you can use your time more efficiently because this application tells you when the bus will come, so you will not waste time by waiting buses. And actually, that is why I made this application. And there's more than 0.6 million iPhone users in Korea. How much? Okay. Almost 500,000 people downloaded this application. And it's almost the 88% of the iPhone users in Korea. And when I saw this number, then I was just proud of it, and it's just an amazing number because almost all of the people who use the iPhone use this application. So it is amazing. And also, these are the reviews on the App Store written in English. So what you can see about is not only the Korean, but also the foreigners who travels to Seoul or who works in Seoul use this application very efficiently, and also they love this application. You can see about it. And from now, I wanna tell you the sad story, the trouble story about this Seoul Bus application happened about 5 months before, and 1 week after the Seoul Bus was released out of the world. And first I got the email like this from, I will translate it later, and I got this email from Gyeonggi Bus System Manager, the Gyeonggi Province Bus System Manager, and this email says to me, if you do not remove Seoul Bus from App Store, there will be a law problem because you use this information without our permission. So you did something illegal. It says like that. So, I was just 17-year-old high school student when I developed it and when I get this email. So I was really afraid. So I just removed this application from the App Store. I just removed, and I called to my father, and Dad, I think I did something wrong, and I think I should go to jail soon. And my father said, you should not have removed, you should not remove this application because the bus information is owned by citizens and owned by us, because we pay for the information like taxes, and they made this information with taxes, so that information belongs to us, so you can use the application, he said to me. So I re-uploaded that application. Yeah, and after I re-uploaded, a couple of days later, that is Gyeonggi bus information, and that was just blocked. They blocked the information because I didn't follow what they want. So, and after they blocked, the users of Seoul Bus who lives in Gyeonggi province, I think they become so angry, and they called to the center, and I don't know what is, but they did something. So, and after that, the governor of the Gyeonggi province, he ordered the manager to unblock. So that information just unblocked right away, and it didn't take a lot of time. So that is a story. And okay. And after this, I've participated to the panel discussion in National Assembly of Korea as panelist, and this is the brochure of that discussion, and you can see the Seoul Bus application screenshot on that brochure, and so that is really amazing. And what this discussion about is opening the public information owned by the government to the people, and that is really amazing, because I've just opened the way to providing the information, and the information will be provided like an API, and I think this opening the API will unleash the possibilities and unchaining the ideas I wrote down there. And what that means is if all of the information is just opened, then developers like me, who had needs and who want to develop an application, they will gather the information provided by government or somewhere else. They will gather that information and make an application like they called a mashup. So they mash up the ideas, they mash up their idea and all of the information and data from the government, and there will be the more convenience application than my application. So like that is, if the information was opened, then the people, the individual developer will develop the application using that information. So I think that will increase the convenience of the public transportation, and it will increase the usage rate of that public transport. So I think opening the public information is great. Yeah. And thank you for listening to me.
Thank you very much, Juan. Not only in perfect English, I must say. What amazes me most is that a high school kid, so to speak, develops that in his spare time. He has to rush home this weekend because he has to prepare for his final exam at high school, and then he becomes a true professional. Any questions? Too convincing. Over there's one.
Yes, I have a question, because in the Seoul area, if I understand it, there are many bus companies. I understand more than 70, maybe even greater if you go beyond Seoul. How was the information that you used, that you mashed up, if you will, how was that information, in what format was that? Was it relatively easy for you to bring all these different information sources together, or were they all different?
There was already the bus information system in Seoul, in Incheon, and Gyeonggi province. There are 3 websites that provides you the real-time information. So I just go to that 3 sites to gather that information, and thanks to that bus information center maybe, and they just made that they gather all of the companies in their province. So thanks to them I was allowed to make that easily. And yes.
If I could just ask a quick follow-up question. This is just for buses right now. But you're younger than most anyone in this room, and surely you have some dreams. Do you think that ultimately one day this type of application will be for buses, for parking spaces, for trams, for metros, for roadways, etc.? Do you see, if there is a common information platform, that this is something that people will have in their pocket now to be able to go across the Seoul region via 5, 6 different types of modes?
You understood the question? Maybe we can translate the question to him.
Okay.
So we get the right answer.
The answer and some supplementary facts. The most important supplementary fact is that he uploaded...
I didn't want the answer. I wanted to ask him the question in Korean, and then he can give the answer. He doesn't need your help.
Okay. In Korean?
Yeah.
Yes, okay.
Repeat the question in Korean to him.
The question was in Korean. Okay. 만약에 버스가 가장 말하자면 지금 한 거는 버스에 대한 것이긴 하지만 나중에 뭐 다른 교통수단 예를 들면 지하철이라든가 또는 뭐 트램이라든가 다른 택시라든가 아니면 파킹이라든가 이런 것도 다 같이 하는 그런 장래 그런 게 이제 개발될 거라고 생각을 하는지 그런 게 주 질문의 요지였어요.
Thank you for the translation. And yes, okay, and yes, if the government allows the individual developer to use that information, then somebody will develop an application that gathers all information, not only the bus, using the bus and subway and parking lot, all that information in one application of the smartphone, and that will develop soon. And government don't need to pay to develop that application. Don't need to pay to company. Please develop the program for us. Just opening that information will make somebody to develop it for free. So, and they will develop for just their needs. But government doesn't have to pay because they develop it. So, yeah, I think there will be more and more convenient application, more than my application Seoul Bus, if the more information will open by the government.
Thank you. One more question?
Okay, it's not a question, it's a comment. It's a rather comment or explanation, some kind of supplementary explanation. I guess he didn't mention that his program was uploaded free, so he didn't make any money out of it, but actually more than 500,000 iPhone users are benefiting from it. And I guess the lack of information on bus is most critical, because in case of subways and trams, there is a relatively simple network, and all the users or even the newcomers to the town can have access to that information very easily. But in case of bus, and especially in a big metropolitan area like Seoul, it's too complicated for a foreigner, even a Korean. I mean, city dwellers like me used to have hard time finding out the bus network and all the arrival information, and that is actually a big detriment to bus use. So what is most important and is the most important contribution is to make that information available and help to increase mass transit share so that we can reduce energy and maybe greenhouse gas emissions for the bright future. Thank you.
Wonderful. We get a final concluding remark from the UITP.
I have a question to you. I'm Hans at UITP. Well, we know that the actual president, Mr. Lee, former mayor of Seoul, was quite instrumental to the bus reform in Seoul. Is he familiar with what you did? And if not, would you like him to be familiar with that?
Does the president know your work? And if not, would you like him to know?
I don't know, but me and my application been to many newspapers or the public newses, the TVs and radios. So I think maybe he will know this, but I don't know exactly, but maybe he would know, maybe.
Okay.
I think.
Well, if he knows, he will be proud of you. Ladies and gentlemen, you have made it. We are a little late, but not too late for the reception and the gala dinner. I wish you a very relaxed, informative and communicative evening, and I want to thank our speakers very much for the very interesting and especially disciplined contributions with our tight schedule. Thank you all very much. Thank you.